Yes. So the mandate which we received from Helvetas was to analyze the situation, the current situation in Ukraine from our perspective as a foreign group of experts, and also to assess references, to analyze references that could be interesting for Ukraine in order to describe the potential of circular reconstruction in your country. So we did this together with Rethink. So Rethink has actually written the second volume of this publication, which goes more into details on the context in Ukraine, on the opinion which they have assessed through interviews with different stakeholder groups, and also about the legal environment and the policy environment in Ukraine. While our part shows more the perspective of urban mining and circular construction. So let me say a few words about Skat. Skat has been founded some 45 years back as a technical support unit for agencies like Helvetas, like the Swiss Corporation, multilateral organizations like UN. And on the map, you can see where we are working. We have also our offices in different countries, many actually also in Eastern Europe. We used to implement a project for STC for nearly 15 years in Ukraine. It was called the DESPRO project, and ended just a few months before the war started. So my name is Daniel Luis, as I mentioned, and Andre Oulal, the co-author. He's also architect and specialist in building in conflict context. He will give you the initial part of this presentation. Before we start, I'd like to quickly mention who is the target group of this study, of this report, which we did. So we are trying to inform the decision makers in this country and also abroad. It is also a document that is useful for homeowners who have actually a building or a house that is damaged, demolition firms, architects, engineers, builders and contractors, also those resellers of building material and the building material industry itself, and then of course also finance institutions. We have worked also with external advisors. There are the Swiss pioneers in circular construction from in situ. We have EMPA, the research institute from Zurich, Zero Waste in Kharkiv, and then research institutions like Haslu, for example. Before we started this report, there was also this conference in Lugano, where which was, I think, the first bigger event where the reconstruction, post-war reconstruction in Ukraine was discussed. And there have been quite important statements from your presidents, but also from EU and from the Swiss president about the importance of environmental aspects in the reconstruction effort for Ukraine. So I think we are well in line with the priorities of the key institutions and the representatives in the country and its environment. So Andre, I would like to give you the floor for the part of the presentation, please.
Thanks, Daniel. Hello, everyone. I'm just going to present a few slides which provides a very broad context for subsequent discussion by Daniel and then our partners at Rethink, who produced the second volume of the report. And I just want to start by talking a little bit about the extent of building destruction in Ukraine. It's something that I'm sure everyone here is all too familiar with. The donut charts that you see on the bottom left there are from the rapid damage needs assessment, the latest assessment that was produced in June 2023 by the World Bank, the government of Ukraine, the EU and the UN, really providing an overview of the extent of damage. And I guess the two main points that I think we can take from there is the sheer scale of damage, $135 billion worth of damage. It's important to highlight, the RDNA report really boils down damage to a financial figure, a dollar figure, and we all know the true costs of the damage are much more than that dollar figure represents. Nevertheless, 135 billion, and to put that in context, Ukraine's GDP prior to the start of the war in 2021 was 200 billion for the year. So it just gives you an indication of the massive scale of damage that's occurred. The second main point to take from here is, from these two charts, is the discrepancy between the cost of the damage and the cost of reconstruction. 135 billion versus 411 billion. And really underpinning that is this principle of building back better. So improving on the infrastructure, the built environment that was in Ukraine before the war, and really setting Ukraine on its path towards, or on its European path, let's say. So total recovery and reconstruction needs of around $411 billion. Again, consider that in the context of the pre-war GDP, annual GDP of around 200 billion US dollars. On the right, we have a few figures which zoom into that damage level a bit more. So again, from the rapid damage needs assessment, 1.5 million homes damaged or destroyed. Now that includes apartments. So if we look at that in terms of buildings, it's around 168,000 buildings, residential buildings damaged or destroyed. And a third of those are assessed to have been completely destroyed. Reconstruction just of that housing, damaged and destroyed housing, is estimated at around $70 billion, the reconstruction costs. And again, to put that in a bit of context, the value added by construction, that is the contribution of the construction industry to GDP in Ukraine in 2001, was 5.5 billion. Now that's just to say that reconstruction is going to involve a massive increase in construction activity in Ukraine compared to pre-conflict or pre-war levels. Now, looking at this from the other side, it's the amount of damage. We've got a couple of figures up there for the amount of demolition waste generated. From the Ministry of Environmental Protection and Natural Resources, there was a figure of 10 to 12 million tonnes per annum. From the Kyiv School of Economics, there was a figure reported of 18 million tonnes of demolition waste. Now, we expect that these are underreported. They're inaccurate and underreported, perhaps because of issues of access to actually undertake accurate assessments of damage. Just to put it in context, in 2022, France's construction and demolition waste was around 86 million tonnes. Germany's around 72 million tonnes. The Netherlands, with a population comparable to that of Ukraine, around 24 million tonnes. All of these without the added load of the damage and destruction from war. The rapid damage needs assessment is currently estimating the cost of just the demolition and removal of debris to be around $5 billion. Daniel, could you go on to the next slide, please? So how do we deal with all of that building and demolition waste? So there is let's say a policy or a legislative framework for doing so. The recently promulgated Resolution 1073 from the Ukrainian Cabinet of Ministers on the procedure for management of waste generated in connection with damage and destruction of buildings and structures. So that provides an overall policy framework, a legal framework for how construction demolition waste can be dealt with at the level of the local government. And now a couple of points to take from that are relevant to us today. Number one is that Resolution 1073 really highlights recycling as an important principle and defines a list of materials from construction demolition waste that should be recycled and or different options for recycling. Just quickly, I know colleagues from Rethink will go into more detail in this, but Resolution 1073 also defines that local governments are responsible for approving demolitions and for dealing with or for setting waste management procedures. And also it defines that the owners of buildings retain ownership of the waste. Considering Ukraine's path or European pathway, the EU Waste Framework directive of 2008 is relevant, and that's currently 2008 was the last time it was published, amended in 2018, but it's currently under revision. The 2008 version called for 70% of construction and demolition waste to be recycled. At the time, 2008, the average in Europe was around 40 to 50%. The overwhelming majority of countries in Europe have now achieved that 70% target. Relevant also is the EU Construction and Demolition Waste Protocol, which goes into a bit more detail on how to deal with construction and demolition waste. It adds the principle of reuse as an important strategy for dealing with demolition waste. And it defines demolition audits and waste management plans and protocols for them as a way of, I guess, promoting and facilitating reuse. In relation to Ukrainian reconstruction and international support for it, the UNDP, UN Development Programme, has the mandate for leading on debris removal and mine clearance. In a recent presentation, so UNDP has been going through a study called Establishing Cost-Effective Debris Management in Ukraine, about to be published, we believe. But looking at early presentation of that report, UNDP has presented 4 different scenarios for how to deal with rubble debris from building demolition. One is that 100% of it goes into landfill. Another is that 50% goes into landfill and 50% into decentralized landfill, then 50% centralized and 50% decentralized landfill, and then finally 75% centralized recycling. Sorry, centralized recycling, not landfill, I should say for those, and 25% landfill. It's important to keep in mind there that UNDP has done assessments of the different environmental and cost impacts of these scenarios, and keeping in mind that movement of the construction and demolition waste is both costly in terms of financial terms and costly in economic terms. Hence, looking at the different options for centralized recycling and decentralized recycling. Daniel, can you go on to the next slide, please? Thanks. So one thing that UNDP hasn't considered in their current study is the option of reuse. So reuse, just to step back a bit, derived from the general principle of circular economy, which distinguishes itself from more conventional economic models of the linear economy, characterized by the extraction of materials, production and distribution and use of products, and then the disposal of those products at the end of life. So in contrast, circular economy really looks at intervening in that linear process and seeing to what extent materials, once they've reached their end of their life, materials and products, can be recirculated back into the cycle. So recycled back in to either production processes and recycling, essentially involving downcycling and then reforming materials for new materials, or reusing, so maintaining the form of the materials and then reusing them in their current form again, often involving some level of repair. You can see down the right here, there is refuse, rethink, reduce, reuse. There might be 5 hours, there might be 9 hours. Ultimately, we all understand this circular economy principle of trying to maximize the value of existing products rather than treating them as waste. Within the context of construction, that's resolved into circular construction. And you can see in the images across the top here, some of the materials that are frequently reused in construction. And keeping in mind that the reuse of circular construction and the reuse of construction materials is rapidly expanding across Europe. You can just see some of the materials here, ranging from structural to structural materials, internal finishes, machinery, internal fittings. I won't go through them all. I think Daniel will discuss in a bit more detail the potential for the different types of materials in Ukraine. Could you go to the next slide, please, Daniel? Finally, I just wanted to end with a few slides of building projects that illustrate the potential of reuse. I'm just going to flick through them quickly, but look, up until recently, reuse of materials really has been restricted to, how would I say, finishes, let's say either internal finishes of buildings, be those skins or cladding, and internal finishes like tiles, and then also fit out materials like sanitary ware. But increasingly, reuse is expanding to include structural materials and materials integral to the building envelope. So the project you're seeing here is quite a prominent example in Switzerland. It's the K118 building by In Situ or Baubureau In Situ Architects based in Winterthur in Switzerland. It's in an old industrial complex. The building uses reused components, structural steel. So it reuses structural steel. Most, if not all, of the building envelope is fabricated from reused materials. That's including the cladding, the orange cladding that you can see in the image, the windows, all of the secondary structure inside, and the insulation. And of course, as with many buildings using reuse, the overwhelming majority of the internal finishes are from reused products. Daniel, can you flick forward, please? Some others, we'll just flick quickly through these. And these are really just to illustrate that idea that building materials can be reused in both structural and non-structural applications. There are a range of different possibilities here that we're talking about, and both from mundane or commonplace buildings, but also, I guess, more architecturally sophisticated examples. Here we have the Ningbo History of Museum in China by a recent Pritzker Prize winner, Wang Shu. Daniel, can you skip forward, please. Again, we'll just skip through these, but this building's primarily using vinyl in its cladding, so it's an external envelope. Daniel? A building from, I believe it's from Germany, but mainly this is interesting for its reuse of concrete, again, in a structural application. Daniel? A building residential complex from Denmark, if I recall correctly. So reusing bricks. And this is important and interesting, I think, for the extensive use of bricks on a very large residential development, just highlighting the potential for reusing bricks within reconstruction in Ukraine. Daniel? That's it, Daniel. I'll hand it back over to you for urban mining. Thank you.
Thank you, Andre. So maybe I can quickly ask also how much time we have left now for the second part of the presentation.
Well, preferably 15 minutes or 10 minutes, but just let's see.
Okay, good. I will rush a bit. So for the audience, there's no need to read all the text. I think this is more supposed to be like subtitles for those who will be reading it later on. So I will actually talk about most of the content, so you can easily focus also on the pictures, which illustrate quite well what I like to share with you now in this second part. So urban mining, some of you might be familiar with that from already old times. I think it was it first came up when it was focusing on rare metals like gold, when a Japanese professor found out that actually within the cities, when there are gold mines equivalent to other gold mines out there, if one recycles or accesses electronic waste, that is just thrown away, and that this is a source of very valuable material. And the same actually applies also for construction material. Nowadays, urban mining is used in a much larger sense. It contains demolition, sorting, cleaning, and then reaccessing, recycling, re-injecting the material into the construction supply chains. There are different types of materials. Some are easy to use or already used for a long time, for generations. Others are more complex. So normally a material that can be carried by hand, easily transported, like windows, like sinks, toilet seats, and so on. These are rather low-hanging fruits for urban mining, while others, like the insulation material, require more processing. These huge damages which we have among the Hrushchevka buildings in your country. Of course, there is a long tradition already for reusing material for urban mining, even if you didn't call it like this. And these are pictures now I took from Ukraine and the environment. So after the war, how people actually sell or avail their materials. Sometimes it's on the plot, sometimes it's along the road. Some use pin walls to inform the village people that they have something to sell, or resellers or availing used materials now in their exhibition yards, or there are, of course, the online marketplaces. We have this also in other countries in Europe, in Switzerland as well. But more and more there are also specialized shops coming up. We call them Bauteilbörsen. It's also quite popular in Germany nowadays. And these are like supermarket or warehouses, outlets where you can find lots of material from transportable sinks to more complex structural elements, stairs, and so on. Some are specialized also for antique building material or for bricks, and of course the scrap steel traders, which always existed, I think, since Industrial Revolution. So in terms of the online marketplaces, we have also those well-known for all type of items. However, for architects, quite often the information you can get on those marketplaces is insufficient to do proper planning. So that's why there have been a couple of different online marketplaces developed specifically for building materials. They allow actually to describe an item more in details, put more precise measures, allow to filter also among the material, which is particularly useful for planners if they really want to integrate the used material in their design. We have also maps on demolition sites. So actually, if an interesting object is being demolished, it can be useful actually to go there and check also what might be available. We have in various places also what we call these circular construction yards. These are places where reusable building material is stocked or actually bulked. Quite often the quantity is an important element for reuse. So if you have only a few items, you cannot really integrate it into a proper building. But as soon as you have enough quantities available, it gets interesting. And this is exactly the purpose of these circular construction yards. Quite often you have also experts there who can actually advise you how to use it, or they also clean or repair items that can be easily repaired. Helvetas has done the same thing on village scale in Roskolozova in Ukraine. So I had the pleasure also to follow this part of the project and to offer some advice. It is the same thing on a smaller scale. You can see we have been bulking bricks here. We tested also their qualities, and then there was this tent with these more mobile items, also those which need protection from the weather, obviously. And there were also a couple of demonstration walls, which we did in order to show how one can actually reuse these bricks for or insulation material to do well-insulated and low-bearing structures with it. However, the question remains, what happens also with these the larger items, those heavy concrete panels, for example, from the Voshevka buildings. So here the problem is that the demolition requires heavy equipment, and also the testing of the quality of the damage. If it's this fire or a shock from an explosion, needs to be assessed. I think this is still a challenge which will have to be looked at closely with research centers and a network of specialists. What we can already see is that the concrete panels for the slab are already being sold or availed for reuse now on several sites. So there are also lots of brick buildings in Ukraine. There we see also they are being demolished now even more rapidly because it's easier to do that. You don't need that much equipment, and quite often also the interior load-bearing structures like the slabs are made of timber or lighter material, which eases the job for demolition and reuse. We have also seen buildings that I followed actually a couple of buildings now through these 2 years. This one here has been heavily hit by and it was declared as non-repairable at the beginning, but then when coming back, I saw, okay, no, it's actually they analyzed it and saw that the shocks were well absorbed. There was not heavy structural damage, so they are repairing it now. Again with bricks of the same type. Now, as Andre mentioned, there is a big need for additional construction capacity, being it on building material production, on construction itself. So we will look at the next part of this of the presentation into the industry, how in other countries the construction industry has integrated the principle of circular constructions, which are the pioneers and the technologies that are being used. Quite often, or the common practice is actually still in many countries, the building waste is being crushed into small stones or crush, being it bricks or being it concrete, and then they are reused, for example, for roads. You can also reuse it for concrete, recycled concrete, or then with bricks. It's quite popular for outdoor as outdoor material. We have seen in damaged buildings that they used crushed bricks in the past for the traditional kind of concrete, lightweight concrete slabs as well, which is still a possibility as well today. However, by crushing is a very cost and also energy intensive process. So very often these recycled materials have actually a bigger CO2 carbon footprint than new material. So the environmental benefit of crushing this material is not that great. There are now a few companies who have started injecting CO2 into this recycling process. So this allows finally to have recycled concrete with a positive environmental benefit. And then, of course, the reclaiming of the concrete panels is by far the best way to reuse them, as I mentioned it earlier. Now, let us look a little bit closer in the reclaiming of bricks. So there are, as you know, lots of brick buildings in Ukraine, particularly in the Kiev and the Kharkiv area. There have been hundreds, if not thousands, of brickyards operated in the past. Now there are newer brick factories with newer products. However, the quality of these bricks is quite well, particularly the very old ones, the Savska Sigla, or the pre-revolution bricks. They are very, very strong. They have very low water absorption, so they are excellent for reuse. And there are methods actually to do that in a very effective way. I know that there is a traditional way to do it already existing for the decades or centuries in Ukraine. However, now for doing it on mass scale, I would like to share with you some pictures of how it is done, particularly in Northern Europe, in Scandinavia, also in Australia and the United States, where the reuse of brick is actually an industry of its own. So you can see here they are carefully removing the bricks during the demolition. There are people who are doing already first cleaning on the construction site itself, and then at this moment they also sort the good from the bad bricks, or those which can be reused directly or which need further cleaning. There are also machines available you can put next to the construction site and then trim the bricks if they have, for example, mortar that sticks too much to the product. So these are examples of companies. I think the bigger picture is from Australia, a brick reclaiming company, and you can buy the products online, or you can get them there. They are in Denmark. They are certifying them with the EU certification. So in terms of quality, it is if a brick goes through that process, it is actually as strong and certifiable as any new modern brick. So the industry is trying to go to larger scale now. So we can already find quite bigger factories in the US, but also the biggest brick producer in the world, the Wienerberger. They are currently working on equipment together with a Danish company for robotized and really large scale processing of reclaimed bricks. In the last part, I have a couple of examples how these materials are used. So we have the spontaneous, unplanned, unengineered way to do it. So this is just a material reseller in Makarif, and also some repaired house, I think from a Helvetas project, I believe. And there are also examples from the past, or also from leading design firms. On the left side, this is a church built after Second World War by Rudolf Schwarz, an architect who pushed to combine the reuse of building materials, at that time, very modernist architecture of excellent quality. And then, of course, you have the more contemporary design also playing with this, the patina of the existing building material. There are wonderful examples in Ukraine as well. So I've been visiting this villa in Kharkiv 3 months ago, and I was impressed by the quality not only of the design but also of the craftsmanship. This is in the Mark House in Kharkiv. It was done as the architect told me with masons, normal masons, so they didn't require extra training for doing that, but a good stimulation, a good supervision, of course. And then you might also know, of course, the theater in Kiev that was done with the same architect with this material. You can also see lots of hotels that are now using reused building material as a key feature for the interior design, also for marketing if you go on their website. And then, of course, plenty of restaurants doing the same. Yes, so Helvetas also asked us, okay, what could be the way forward now after what we have analyzed, what we have seen in the field, after the potential which we have observed and assessed. And the question was, at one hand, okay, we have done now this circular construction yard for that village, Rusko-Lozova. And would there be a possibility actually to grow or to learn something from that experience and to do a next step? So what our suggestion actually was is that, or the finding of our analysis was, for a village context with lots of damaged houses or lots of damaged brick houses, this is probably the right size for which could actually be replicated in many villages. So it is a very low cost. It doesn't require a permanent presence. It is a place where you collect material and where you re-avail it, either commercially but also free of cost, as it is currently the case for certain of those materials. You can connect it also to construction yards that are specifically related to a demolition site, where you are actually sorting all the different materials and trying to re-injecting it into the construction supply chain. And then I think an important element could be an urban outlet where the best material, the one with the highest value, is availed for urban clients. And these can also achieve quite high prices. We can see that already from the existing building material resellers. So a triangle between the green, the blue, and the orange dots here will probably allow this to grow and to optimize the reuse of reclaimed material. The second question we've been asked to look at is also how to continue with demolition and building, with demolition of damaged buildings in a smart way, and then rebuilding buildings with the same material. So here we have a couple of steps which we imagine would be useful to start rather soon. So the first the first step is certainly to identify a suitable building that allows relatively easy demolition and reclaiming of the bricks at a high quality level. We have seen there are many of them. I think it's good also to have a well-located place where people can see how this works in practice. So, and then of course to implement it, to find out what is the most cost-effective and the safest way also to demolish such a building. Then this material needs to be tested. I think there is a need for protocols to certify the quality of these products. We can already use examples and protocols that exist out there. And then based on this, we can also design new ways to use that material in order to meet the environmental and structural standards of today. There are experiences out there. We have done this in the Balkans already to a certain degree, and there are others who have similar experiences. And then the third step, which is I think very important, is to start very rapidly with a real building. It is as a complete building, not a complex, but a simple one that allows to show also the quality one can achieve with it. We did that in different contexts already in the past. What you can see here is a model building at the UN Habitat headquarters, which we just inaugurated last summer, which had actually this walling system that you have seen before, which can be filled with waste insulation material as well, but there can be plenty of other designs as well. But it's important to show that the performance, to measure it, and also to see the architectural quality you can get with this special surface of reused material. The one thing that would certainly make sense in the context of Ukraine is looking closer at these standardized buildings, the Hrushchevka buildings particularly, so being it those made of bricks or those with concrete, to do the inventory, to check what is actually, how much material is there, how to demolish it or dismantle it in a way that they can be reused best, and then also to think about what can be built with it ideally. So because you have these same buildings thousands of times, I think this is not only useful for post-war reconstruction, but also for the future once these buildings need to be replaced or upgraded. And as I mentioned before, when this happens, there is a circular construction yard required to sort the material, to test the quality. And then after that, I think it would make sense to build the first building, a first demonstration building at full scale, being it an apartment block, a public building, a school, or whatever. This is a building from Australia. Also, it's a residential building made of reclaimed bricks, something of that kind, of any other shape. Would certainly make sense in order to show also the entrepreneurs, the banks, the investors, what reused material can actually do. And as a last step, this last slide, there will be research required to see the long-term, mid-term performance of reused material. And there are institutions that have expressed already lots of interest in doing that. One here is the EMPA, the Nest building, which is actually designed to test a variety of different construction systems on an accelerated long-term simulation. So one could also try, for example, the upcycled Hrushchevka panels or any other material in such a facility. Thank you for your attention.
Thank you.